Alright, welcome. And for the topic 8IB, you need to be able to understand and describe what's going on with the greenhouse effect. And so let's start by just learning a little bit about what it's not. Most people think that you've got your Earth here, you've got your atmosphere up here, and you've got coming in all of this radiation, and that it comes in, hits the Earth's surface, and is bounced and trapped by this being the atmosphere. And then it just continues to bounce around, and that is what makes the Earth's surface heat up. That is wrong. Don't think that. What is actually happening is you do have the Earth surface, and you do have your atmosphere, and you have all the sunlight coming in. Some of it does bounce off the atmosphere and never makes it. Much of the visible light, though, will go through and hit the Earth. Some of it does get absorbed by land. Much of it does, though, bounce off. And since it came through in the first place as visible light, much of that visible light will escape. It doesn't get trapped and bounce around like most people think. Now, the amount that does reflect off here will depend on our old friend albedo, which, remember, we learned about as a little symbol, fish symbol there. And if it's ice and water, has a high albedo, much of it goes away. Maybe it has a 0.8 albedo. Or if it has a very low albedo of 0.1, like for a forest, then much will be absorbed. Some of this that does get absorbed does get emitted. And if you remember, this emittedness depends on the emissivity, which we learned about already. And if it is a dark surface like forest, it'll have a high emissivity, and if it's a shiny surface, it'll have a low one. But this that is emitted, it's emitted as infrared, no longer visible. And this infrared stuff does then get absorbed by greenhouse gases. Greenhouse gases. Like carbon dioxide and water vapor. We'll get to that in a minute. But since it gets absorbed, it then does get re-emitted. Some of it gets re-emitted out into space, but much of it does get re-emitted back to Earth. So it's absorbed by greenhouse gases and re-emitted back to Earth. And this is important because it's this re-emittance of the infrared radiation that keeps the Earth's temperature at a reasonable point. If we didn't have this re-emission of greenhouse gases, then the Earth would be too cold, and our constant temperature would be well below zero. So the greenhouse gases in this case do a very good service for us, as long as there's not too many of them. Now, just a little bit close up on what happens with greenhouse gases. Let's explode all this, and let's learn a little bit about why these greenhouse gases are absorbed. You've got, let's say, one atom and another atom, and these are two atoms that are bouncing around on a spring. Boing, 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 boing. They're going like this at a certain frequency, let's say. And our greenhouse gases could be something like carbon dioxide, water vapor. Most people don't know water vapor is a greenhouse gas. It is. Nitrous, also known as laughing gas at the dentist. And maybe methane, which is what comes out of farm animals and lots of other things. And this has a certain frequency f that it likes to vibrate at. Visible light may come bouncing off the surface of the Earth and go right through it, because for visible light, its frequency is too high, and it goes right through the greenhouse gases. But if you have something like infrared radiation, this greenhouse gas guy is going to say that frequency is just right. And that greenhouse gas molecule is going to absorb it, because the frequency of the infrared is the same as the resonant frequency that the molecule likes to vibrate. And so it'll quickly start vibrating like crazy at a higher energy level, and then it will re-emit that again and keep the Earth quite warm. That's it. That's the greenhouse effect. Woo!